Hello everyone. So we are going to solve today's Leetcode problem, Leetcode 1155, number of dice rolls with a target sum. So this is a DP problem. So the question is, given three integers n, k and target, return the number of possible ways out of k power n total ways to roll the dice so the sum of the face up numbers equals target. Since the answer may be too large, return it modulo 10 power 9 plus 7. So we have given three integers n. N means the dice index or number of dice. K means number of faces on each dice. And target is the sum. Okay. So we are given n, k and target. We need to find the number of possible ways out of k power n total ways so that the sum will be the target. So let's take an example. Let's take this example: n equal to 2, k equal to 6, target equal to 7. So n equal to 2, k equal to 6, target equal to 7. That means we have two dices, right? And each dice has six faces, like a normal dice. So each dice has from 1 to 6 values. So we need to roll a dice in such a way that the target is equal to 7. Suppose, what are the cases here? Suppose we have rolled two dice and the first dice we got number 1 and second dice we got number 6. So this is one possibility. Similarly, if we have number 2 here and number 4, okay, this is one possibility. Suppose if we have 6 here, 6, no, this is not a possibility because the target sum is 7, right? So if you can see in the question, they have given the number of possibilities here: 1 plus 6, 2 plus 5, 3 plus 4, 4 plus 3, 5, 2, 6, 1. These are the possibilities here. So answer is 6. Out of how many possibilities? Normally we have k power n possibilities, meaning so if we have one dice here, 1 is there, right? We have, if we take 1, then we have how many possibilities here? We have 6 possibilities, right? 1, 2, 3, 4, 5, 6. So we have 6 possibilities here for each one. Okay, so we have 6. Now we have 2. Then also we have 6. Like that, 6 plus 6 plus 6 plus 6 plus 6 plus 6, right? That is k power n. K power n. The formula is k power n. K here is 6 power n2. So 36. So we are writing 6 times 6, right? So there are total 36 possibilities of all combinations like 1 1 1 2 1 3 dot 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 2 1 2 2 2 3 dot dot dot, like that. And we need to find a possibilities whose sum equal to target, right? Which is 7 here, and we have 6 possibilities. So we are going to do that. This is a DP problem. First we'll do the recursion. So let's suppose int solve. Now what we need the number of dice, which dice we want. Here you can see, right, here we have two dices, so there are 6 possibilities, but n can differ. Here we have 30 dices and we have 500, target as 500, and each dice has 30 faces. So in the sense, if we go for a big number, n equal to how much? 30, 30, 500, right? N equal to 30, k equal to 30, target equal to 500. So if you take dice 1, right, this is the first dice, and second dice we have a number 2, right? It can be 2 or 30 or anything. Let's suppose we have 2 and we have number 3 and so on. If we have like 7 or 8 here, so this is first dice, second dice, and 30th dice. This sum should be a combination so that the sum will be 500, right? This can be, let's say, 30 also, right? Here 29, etc. So we need to find a combination of these 30 dices so that the target is 500. How to do in a DP? Simply we need to take one dice and we'll do all the combinations, and we'll take the second dice here and we'll do all the combinations, etc. like that. Let's see how the code looks like. You'll get to understand better. So first, int dice index, right? Which dice we are taking? We'll go dice wise, first dice, second dice, third dice, and now int remaining target. So we'll take one dice and we'll take the remaining target, means we'll subtract each one and go on like that. So if you can see here, we have one, right? We took one, so remaining target is 500 minus 1 equal to 499. We'll go to the second dice here. This dice can be 2, 3, 4, etc., right? If it's a 4, then 499 minus 4, we have chosen 4 here. Next, out of 28 dices, we need to find a combination whose sum will be 499 minus 4, 495, right? Like that, we'll go choose an each dice, we'll subtract the value from the target, and at last if it reaches 0, the target reaches 0, then it's a valid combination, right? The same thing we are doing here. In remaining target, we'll also take n and k, number of dices and faces on each dice. We'll write base condition. Base condition is if dice index equal to n, return rem target equal to 0. So here you can see, right, if dice index equal to n means we have reached the last dice. In this last dice, if the remaining target or target here remaining target equal to 0 means this is a valid combination. If it's not equal to 0, then this is an invalid combination. Same thing. If remaining target equal to 0, it's a valid combination, or else it's an invalid combination. Also, if rem target less than 0, right, return 0. If rem target equal to 0, it will return 1, or else it will return 0. Here, if rem target is less than 0, we need to return 0. Suppose we have target 5. If this is 5, and if we take 1, 4, 3, 4, 5, 6, 7, 8, right? 8 minus 5 equal to minus 3. So here only the combination failed. So we'll return 0, false. Okay, now it's done. Now we'll do int answer equal to 0. Now the logic happens here. For int face. So what are these? Now we have n faces, right? Here k is nothing but number of faces. Here we have 6 faces, 30 faces. So face equal to 1, face less than or equal to k, face plus plus less than or equal to k, face plus plus, answer equal to answer plus solve what dice index plus 1 comma rem target minus face comma n comma k, right? So as you can see here, what are we doing? We have chosen one dice index. This is the chosen index, and then for this dice index the next solvation will be dice index plus 1. So we'll go to the next index and we'll also decrease the face value from the remaining target. That means we have chosen 1, and then we'll pass n comma k. So these two are variables here, dice index plus 1 rem target minus face. Like here you can see, first we are going to solve for this. That means we have chosen this one, then we'll move on to other and we'll decrease the target. Then we have chosen this, we'll move on to other, decrease the target, and so on, right? Like that. So this is the condition, and at the end if it's 1 it will return 1, if it's 0 it will return 0, like that. Return answer, that's it. So here we can see return solve 0 comma target comma n comma k. And one thing we need to check is return it modulo 10 power 9 plus 7, right? We'll define a mod, hashtag define mod 10 power 9 means 9 zeros 1 2 3 4 5 6 7 8 9 and plus 7. So we'll remove the last and keep 7. So at every point we need to do mod. Okay, answer, here we have answered it. We'll do a mod here. So okay, we'll run. Yeah, it will be time limit exceeded because this is not time efficient. What to check whether this is correct or not, we'll remove the last case. So first case is 1 6 only, second case is 2 6, third case is 30. We'll remove this case and check once. Yeah, you can see here this run, but as you can see for the third case the time limit got exceeded. So for that we need to do memorization or memoization. So the thing is, here comes the dp. Basically we need to store. So we have vector int dp. Okay, this is a global, I declared it globally. So why we taken vector means we basically need to store this dice index and rem target and the answer. So here these two are only changing, right? N comma k are not changing. So for each dice index and rem target there will be an answer, this written answer. We need to store that. First let's do resize. So n plus 1 comma vector int target plus 1 comma minus 1. So we took up to n plus 1 and target plus 1 and we did minus 1 here, means we initialized everything with minus 1. Now we need to store here. How are we going to store? Here, right? dp of dice index comma rem target equal to answer dot mod. So for this dice index, for this remaining target, we are storing the answer here, whether it can be 0 or 1 or anything, answer plus solve, right? It can be 2, 3, etc., anything. For each dice index and rem target we are storing. And if dp of dice index rem target not equal to -1 means we have already solved this for each dice index and rem target. Simply we are returning dp of target. We'll run this. So basically, instead of solving everything, solving this for loop, we are just returning it here only, so that uh, we don't have to go through this for loop and solve the sub cases again. Yes, you can see here, right? Yeah, so it's a DP problem. It's a medium level DP problem. Yeah, thank you.